Hello student. Dear student, in the previous video we discussed two electrical properties. So in this properties we discussed two conductors, insulator and semiconductors. So the solid width conductivity ranging between 104 to 107 ohms per per meter are called conductors. Metal have conductivity in the order of 107 per ohms per meter are good conductors. And insulator, these are the solid with very low conductivities ranging between 10 power minus 20 to 10 power minus 10 ohm per meter. And semiconductors, these are the solid which conductivities in the intermediate range from 10 power minus 6 to 10 power 4 per ohm per meter. So this is the electrical properties. And the next topic, conduction of electricity in metals. So metal conduct electricity in solid as well as molten state. And the conductivity of metal depend upon the numbers of valence electrons available per atom and the atomic orbital of metal atom from molecular orbitals which are so close in energy to each other as to form a band. If this band is partially filled or it overlaps with a higher energy unoccupied conduction band, then electrons can flow easily under an applied electrical field and the metal show conductivity. If the gap between field band and the next higher unoccupied band, conduction band, is large, so electrons cannot jump to it, and such as substance has very small conductivity and it behaves as an insulator. So the next slide, the conductivity of this instances semiconductor is too large to be practical use. Their conductivity is increased by addition appropriate amount of suitable impurities. This process is called doping. So doping can be done with an impurity which is electrons rich or electron deficient as compared to the intrinsic semiconductor silicon or germanium. Such impurities introduce electronic defects in them. And the next slide, electron rich impurities. Silicon and germanium belongs to group 14 of periodic table and have 4 valence electron each in their crystal. Each atom form force covalent bond with its neighbors. When doped with a group 15 elements like phosphorus or arsenic, which contains 5 valence electron, they occupy some of the lattice sites in silicon or germanium crystal. And 4 out of 5 electrons are used in the formation of 4 covalent bonds with the 4 neighboring silicon atoms. The fifth electron is extra and becomes decollized, and these decollized electrons increase the conductivity of doped silicon or germanium. Here the increase in conductivity is due to the negatively charged electrons. Hence silicon doped with electron rich impurities is called n-type semiconductor, like that. So here the perfect crystal, the first structure means number A structure is a perfect crystal, silicon atom, and second is a mobile electrons, n-type semiconductor, and this is the boron means positive hole, no electron. So this is the p types of semiconductor. And next, application of n type and p type semiconductors. So diode is a combination of n type and p type semiconductor, and it is used as a rectifier, and transistors are made by sandwiching a layers of one types of a semiconductor between two layers of the other types of semiconductor. NPN and PNP types of transistors are used to detect or amplifier ratio of audio signals. The solar cell is an efficient photodiode used to conversion of light energy into electrical energy. Germanium and silicon are group 14 elements and therefore have a characteristic valence of 4 and form 4 bonds. Like the diamond, a large variety of solid state material have been prepared by combination of group 13 and 15 or 12 and 16 to simulate average balance of 4 as in germanium or silicon. And transition oxide including vanadium also have high electrical properties. And the next slide, magnetic properties. Every substance has some magnetic properties associated with it. The origin of these properties lies in the electrons. Each electron in an atom behaves like a teeny magnet. Its magnetic moment originates for two types of motion. Number one, its orbital motion around the nucleus, and second, its spin around its own axis. Number two, electron being a charged particles and undergoing this motion can be considered as a small loop of current which possesses a magnetic moment. Thus, the electron has a permanent spin and an orbital's magnetic moment associated with it. Magnitude of this magnetic moment is very small and the measuring in the unit called Bohr magnetons. Mu b. It is equal to 9.27 into 10 power minus 24 angstrom meter square. On the basis of their magnetic properties, substance can be classified into five categories: paramagnetic, diamagnetic, ferromagnetic, interferomagnetic, and ferrimagnetic. So this is the some magnetic properties and other topic we discuss to our next video.